Welcome to another lesson of Math 1314 College Algebra. Today we will be discussing sections 1.6 and 2.2, which are rational expressions and equations. Now we've covered most of 2.2 already and included a lot of the rational equation discussion in that section, but this will be a review of that section as well as performing operations on rational expressions and solving rational equations. So the things that we should be prepared to do after. So how do we simplify a rational expression? Well, the first step we need to do is we need to factor the numerator and then factor the denominator. And then we want to cancel out any common factors in the numerator and denominator. Let's try an example. Okay, our example here says to simplify the rational expression x minus 6 over x squared minus 36. Well, can we simplify and factor the numerator? No, the numerator is already fully factored. How can we factor the denominator? Well, the denominator looks like a difference of squares to me, so I will rewrite that as x squared minus, what's the square root of 36? 6 quantity squared. So this is equal to x minus 6 all over x plus 6, x minus 6. Then I can cancel the x minus 6's, and I'm left with 1 over x plus 6. And that's my final answer. Let's try another example. We want to simplify x squared minus 9 all over x squared plus 4x plus 3. So we'll first factor the numerator. And again, this looks like a difference of squares, so that's equal to x squared minus 3 squared all over, what are the factors of 3 that give us positive 4? That's 1 and 3, so x plus 1, x plus 3. And the numerator can be factored as x plus 3, x minus 3 because of the difference of squares. So we have x plus 1, x plus 3 in the denominator. So the x plus 3's cancel, and we're left with x minus 3 over x plus 1. And you can drop those parentheses. Okay, let's now move on and discuss how to multiply rational expressions. If we are given two rational expressions, how can we multiply them together? Well, we have steps for that also. First, you need to factor the numerator and the denominator. Then you can multiply the numerators together and the denominators together, and finally you can simplify. When you multiply those numerators and denominators together, if you have common factors in the numerator as you do in the denominator, you can cancel those out as we've done previously, and then you can simplify. Let's try an example of multiplying rational expressions. In this example, we want to multiply the rational expressions and show the product in simplest form. So we have x squared plus 11x plus 30 over x squared plus 5x plus 6 times x squared plus 7x plus 12 over x squared plus 8x plus 16. So we have four separate trinomials in the numerator and denominators that we need to factor. So let's start with the numerator on the left-hand side first. What are the factors of 30 that when we add them we get 11? So let's try those out. So the factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. Okay, so the sum that we need is 5 and 6. So in the numerator, we'll have x plus 5, x plus 6. And in that denominator, we have x squared plus 5x plus 6. What are the factors of 6 that when we add them, we get 5? I believe that's going to be 2 and 3, x plus 2, x plus 3. We'll erase that. And then we'll have times the numerator. What are the factors of 12 that when we add, we get 7? 4 and 3 is what that looks like. X plus 4, x plus 3, all over. Now we're looking at the factors of 16 that when we add, we get 8. And I think that's going to give us x plus 4, x plus 4. So what we then can do is multiply all the numerators together and all the denominators together. So that leaves us with x plus 5, x plus 6, x plus 4, x plus 3, all over x plus 2, x plus 3, x plus 4, x plus 4. Now, anything that's common in the numerator and denominator, we can cancel. So there's an x plus 4 in both places, an x plus 3 in both places, and we're left with x plus 5, x plus 6, all over x plus 2, x plus 4. And that's our final answer. Box that in. That's how you multiply rational expressions. Now let's talk about dividing rational expressions. What happens if we are given two rational expressions and we're asked to divide them? Well, it's very similar to multiplication, except our first step is different as we need to rewrite the product of two rational expressions, the quotient of two rational expressions as the first rational expression multiplied by the reciprocal of the second, meaning you flip the second rational expression for the division. Then you proceed exactly as multiplication, factoring the numerators and denominators, multiplying the numerators together, multiplying the denominators together, then simplifying. Now that we have the steps for dividing rational expressions, let's do an example. In this example, we want to divide the rational expression and express the quotient in simplest form. We have 9x squared minus 16 over 3x squared plus 17x minus 28 divided by 3x squared minus 2x minus 8 divided by or over x squared plus 5x minus 14. So the first step in simplifying this quotient is to rewrite as the first rational expression, that's this part, multiplied by the reciprocal of this part. That means to flip that. So let's rewrite it. That's 9x squared minus 16 over 3x squared plus 17x minus 28 times x squared plus 5x minus 14 all over 3x squared minus 2x minus 8. So let's begin factoring numerators and denominators. The numerator is a difference of squares. So we have the quantity 3x squared. So that gives us a 3x plus 4, because that's 4 squared, and a 3x minus 4 in the numerator. In the denominator, we need to look for the factors of 3 times negative 28 that add to 17. 3 times 28 is 84. The factors of 84 that give us negative 17, I believe, give us, what is that? Let's see. 21 and negative 4. So we can rewrite that as 3x plus 21x minus 4x minus 28. And then we'll just copy the rest. X squared plus 5x minus 14 all over 3x squared minus 2x minus 8. So we can factor by grouping. So we keep the numerator the same. So we can factor out a 3x, I believe. So 3x times x plus 7. And then we can factor out a negative 4. And we're left with x plus 7. Copy down the second half. Okay, then our final factoring by grouping gives us 3x plus 4, 3x minus 4, all over 3x minus 4, x plus 7. And then the second expression, we need the factors of negative 14 that when we add, we get 5. So I think that's 7 and negative 2. So that gives us x plus 7, x minus 2. And in the denominator, we need to look for the factors of 24 that give us a negative 2. I believe that would be, let's see, let's write those down. 24, we get 1 and 24. We get 2 and 12. 3 and 8. 4 and 6. So I think a negative 6 and a positive 4 will get us that. So we get 3x squared minus 6x plus 4x minus 8. We're almost there, guys. All right. One more copy here. 3x plus 4. 3x minus 4. All over 3x minus 4. X plus 7 times x plus 7, x minus 2. We can factor by grouping here, just like we did on the denominator earlier on the other side. We can factor out a 3x. We're left with x minus 2. And we can factor out a 2. No, let's factor out a 4 plus a 4. That gives us x minus 2. There we go. And then one more simplification step before we start to cancel. We can rewrite that as 3x plus 4, 3x minus 4, (3x minus 4), x plus 7. And we'll just go ahead and write these numerators and denominators multiplied together. X plus 7, x minus 2. And then we can combine the others as x minus 2, 3x plus 4. So what cancels? Well, we have the 3x plus 4s that cancel. We have the 3x minus 4s that cancel. The x plus 7s that cancel. And the x minus 2s that cancel. So what does this simplify to? Well, all we're left with is 1. So all of that factoring, all of the 4 different trinomials, this division gives us just 1. Okay, let's move on and try adding and subtracting rational expressions. That's a little bit different than multiplying and dividing, but it looks like we've tried about the hardest multiplying and dividing problems that we could do. We did a lot of factoring, so let's move on to adding and subtracting rational expressions. One of the most important parts about adding and subtracting rational expressions is the term least common denominator. The least common denominator of a rational expression is all of the distinct factors of both expressions. And the way that you find those distinct factors is by factoring the denominators. Then we can multiply together all of those distinct factors. This will help us be able to add and subtract rational expressions. So let's say we have been given two rational expressions. How do we add or subtract them? Well, first you factor the numerators and denominators. Then you find the LCD of the expressions as we discussed. Then you can multiply those expressions by a clever one, which is the LCD in the numerator and the LCD in the denominator. Then you can add or subtract the numerators, and finally you can simplify. Let's try an example of adding and subtracting rational expressions. Here in this example, we want to subtract the rational expression 3 over x plus 5 minus 1 over x minus 3. Our first step would be to factor the numerator and denominator, but we find that both numerators and denominators are fully factored. What is our LCD of the expressions? Well, the LCD is the product of all of the distinct factors in the denominators. In this case, that is x plus 5 and x minus 3 because there are no other factors, no other distinct factors. So we need to multiply each term by a clever one to get this whole thing, x plus 5, x minus 3, in the denominator. So the first term we need to multiply by x minus 3 over x minus 3 to get that LCD as the denominator, minus an x plus 5 over x plus 5 times the second part, which is 1 over x minus 3. And that will give us the same denominator for both terms. So what we're left with is 3 times x minus 3 all over x minus 3 x plus 5 minus x plus 5 over x plus 5 x minus 3. So now we can just subtract the numerators. Now that we have a common denominator, let's combine that into one numerator. We have 3 times x minus 3 minus x plus 5 all over x minus 3 x plus 5. Okay, so then distributing, we get 3x minus 9 minus x minus 5 all over x minus 3 x plus 5. And then we can combine like terms. 3x minus x gives us 2x. Negative 9 minus 5 is negative 14 over x minus 3 x plus 5. And then we can factor out a 2 in the numerator. And we're left with x minus 7. 2 times the quantity x minus 7 over x minus 3 x plus 5, which is our fully simplified answer there. See if I can draw a better box. And that is our answer. Now we've multiplied, divided, added and subtracted rational expressions. Now let's simplify a more complex rational expression. So what happens if we have a really complex, complicated rational expression? Please note that complex here does not mean complex or imaginary numbers. This means complex like complicated. Well, first we need to combine the numerator expressions into a single rational expression. So if we have, pluses or minuses, addition or subtraction in the numerator, we need to try and combine those into a single expression. Then we want to combine all the expressions in the denominator into a single rational expression by adding or subtracting. Then we rewrite those two numerator and denominator as a division problem, which we can then flip the denominator and then multiply and simplify. Now that all sounds sort of complicated in and of itself, but let's try an example to try and break this down. Okay, so here we have x over y minus y over x all over y, and we want to simplify this. So the first thing that we want to do, using the steps we discussed, is we want to combine the expressions in the numerator into a single rational expression. So that means we need to find the least common denominator of x and y. Well, the least common denominator of x and y is x times y. So we'll multiply by clever ones to get xy in the denominator. So the first term we need to multiply by x over x times x over y minus, this time we need to multiply by y over y over x, and then that's all over y. So this equals x squared over xy minus y squared over xy all over y, which is equal to x squared minus y squared all over xy. So we've simplified that part. And then we need to do the same thing with our denominator. Well, that's just y over 1. So we have a rational expression divided by a rational expression. So let's rewrite that as x squared minus y squared all over xy divided by, y over 1. Well, if we're dividing, we need to then rewrite as multiplication. So we flip the second expression to get x squared minus y squared over xy times 1 over y. Okay? So then we can multiply numerators and denominators, and we get x squared minus y squared. That's multiplying the numerators together. And then all over x times y, which is xy squared. Now, is that as simple as we can make this? Well, given the tools that we have in our toolkit that we learned in Chapter 2, we actually can simplify this further by factoring the numerator because we have a difference of squares. So therefore, we get x plus y, x minus y, all over xy squared. And both of these answers would be acceptable. Okay, well that concludes 1.6. Let's move on to 2.2 and remind ourselves the definition of a rational equation. A rational equation contains at least one rational expression where the variable appears in at least one of the denominators. Let's also recall, for solving a rational equation, the first step is to factor all denominators, then find and exclude values of the variable that cause the denominator to be 0. Then we find the LCD. Then we multiply both sides of the equation by the LCD to clear the denominators. Then we solve the equation and check your answer. Now, I've gone through a number of these examples in the 2.2 section before, but we will do one example and then we'll close out this section. Let's try an example. In this example, we want to solve negative 3 over 2x plus 1 is equal to 4 over 3x plus 1 and state the values that are excluded from contention for solutions. So first we factor all the denominators in the equation. Okay, this equation is already fully factored, so we want to find the LCD after finding the values that cause this to be 0. So the values that cause the denominator to be 0 are 2x plus 1 equal to 0. We're trying to find where it is equal to 0. And 3x plus 1 equal to 0. So we can solve those. Subtract 1 from both sides. 2x is equal to negative 1. Divide both sides by 2. X is equal to negative 1/2. And subtract 1 from both sides. 3x is equal to negative 1. Divide both sides by 3. And so x is equal to negative 1/3. So both of these two values cause division by 0. And are excluded. Okay, so now we want to solve the equation. So we first find the LCD, and that will be all of the distinct factors. So 2x plus 1, 3x plus 1. And then we can multiply both sides of the equation by this LCD. So we have 2x plus 1, 3x plus 1 times negative 3 over 2x plus 1 is equal to 2x plus 1 times 3x plus 1 times 4 over 3x plus 1. So on the left-hand side, the 2x plus 1s will cancel out, and we're left with negative 3 times 3x plus 1 is equal to, the 3x plus 1s cancel out here, we're left with 4 times 2x plus 1. Okay? Now we can distribute. We have negative 9x minus 3 is equal to 8x plus 4. We now add 9x to both sides. Negative 3 is equal to 17x plus 4. Now we subtract 4 from both sides. We're left with negative 7 is equal to 17x. We divide both sides by 17. And we get x is equal to negative 7 over 17. Now it would be wise to go back and check. And so that is my challenge to you, to go back and check to make sure that negative 7 over 17 is a solution for this equation. That concludes our discussion of rational expressions and equations. Please let me know if you have any questions over the homework via email, and I look forward to seeing you in the next lesson.